Welcome. In this session, we are going to understand logistic regression. We are going to introduce logistic regression with R programming in this session. Let's get started. As far as logistic regression is concerned, first we like to introduce you with linear regression basics and we'll proceed towards logistic regression. Linear regression includes simple linear regression and multiple linear regression. In order to understand that, you can watch our previous video series on data science with R. In both type of regression, we have a dependent variable or response variable as a continuous variable that is normally distributed. However, this is not always the case. Often, the response variable is not normally distributed. It may be a binary variable following a binomial distribution and taking the values of 0 or 1 or no or yes. It may be a categorical or discrete variable taking multiple values that may follow other distributions other than the normal one. If the response variable is a discrete variable which can be nominal, ordinal or binary, you use a different regression method known as logistic regression. If the response variable takes binary values such as yes, no, sick, healthy, or multiple discrete variables such as strongly disagree, strongly agree, partially agree, do not agree, we can use logistic regression in those cases. Logistic regression is still a linear regression. Logistic regression with the response variable taking only two values such as yes, no, or sick, healthy is known as a binomial logistic regression. A logistic regression with a response variable that can take multiple discrete values is known as multinomial logistic regression. I would like to introduce you with some of the examples and let's consider the following examples here. Let's say you want to decide whether to lend credit to a customer. Your choice may depend on various factors including the customer's earlier record of payment regularity with the other companies, the customer's credibility in the banking and financial sector, the profitability of the customer's organization, and the integrity of the promoters and management. These may be some of the factors in order to lend the credit to a customer. You are deciding whether to invest in a project. Again, your choice depends on various factors including the risk involved, the likely probability, profitability, the longevity of the project's life, and the capability of the organization in the particular area of the project. Let's say you are deciding whether to hire a particular candidate for a senior management post. This choice may depend on various factors including the candidate's experience, past record, attitude, and suitability to the culture of your organization. You are deciding whether a particular employee is likely to stick with the organization. This choice may depend on various factors including the internal working environment of the organization, whether the employee is deployed on a challenging project, whether the compensation to that employee is commensurate with the industry standard, and whether the employee is technically good enough to be viewed by other organizations. Interactions between the predictors as well as multicollinearity may still be issues in logistic regression and they need to be addressed appropriately. However, the assumption of linearity, normality, and homoscedasticity that generally apply to regressions do not apply to logistic regression. A starting point for building any logistic regression model is to get your data in a data frame format, as this is a requirement of the GLM function in R. As you saw in previous videos, the GLM function with the syntax family is equal to function Gaussian, and within this the value provided link is equal to identity is equivalent to the LM function. The requirement is that the response or dependent variable should be distributed normally. However, when you use GLM for logistic regression, the response variable takes the binary values and you can specify that with a binomial function, and you can specify the link is equal to logit. Why is that so? So here, because we want the value to be between 0 and 1, hence we have used the function binomial. This can be interpreted as probability. We use the natural logarithm of the odds ratio and it the natural logarithm of odds ratio is equal to logarithm of probability of success divided by 1 minus probability of success. So the logit function is as follows. So logit of the probability of your response, like yes or no, so this is the value which has to be predicted, is equal to b naught plus beta 1 into independent variable 1 plus beta 2 into independent variable 2 till independent variable n. So we are going to discuss this particular equation as soon as we progress further. This equation is also known as the logistic regression equation. We use the maximum likelihood method to generate the logistic regression equation that predicts the natural logarithm of the odds ratio. From this logistic regression equation, we determine predicted odds ratio and the predicted probability of success. So predicted probability of success is equal to predicted odds ratio divided by 1 plus predicted odds ratio. Here we do not use the dependent variable value as it is. Instead, we use the natural logarithm of the odds ratio. Thank you for watching.